Hey everyone, welcome back to The Explainer, brought to you by Forge College. So in our last lesson, we tackled forwarding algorithms and priority handling. Today, we are taking a massive leap forward. We're building a real bug-hunting engineering blueprint by applying coverage analysis to our test suites. We're going to transform those abstract metrics into a concrete, automated defense system for your smart contracts.
Okay, here's our game plan for today's explainer. We'll be hitting 1. The percentage illusion, 2. Mapping execution to source, 3. Triaging uncovered code, 4. The coverage workflow, 5. Automating with scripts, and finally, 6. The iterative feedback loop.
All right, Section 1, the percentage illusion. Let's just jump right in by debunking a massive industry myth about test suite safety that almost everyone falls for.
Seriously, I want you to ask yourself, is 95% coverage actually safe? I mean, does seeing that big, beautiful, A-grade percentage at the bottom of your terminal output truly mean your smart contracts are immune to exploits? Spoiler alert, probably not. You know, trusting a high overall percentage is kind of like carrying water in a bucket that has only a few holes in it. Sure, 90% of the bucket is perfectly solid steel, right? But that remaining 10%? That little sliver could be your critical air handling paths or some super complex logic branches. Leaving those untested is basically like drawing a massive welcome hackers blueprint right on the front door of your DApp.
So we absolutely need to stop staring at these abstract high-level percentages and start focusing on actionable data. Knowing you have 85% coverage, honestly, that doesn't help you write your next test. But knowing that lines 42 through 45 in your token contract are completely uncovered, well, now that gives you a concrete target.
Moving on to Section 2, Mapping Execution to Source. Now the magic here is figuring out how tools like Foundry actually acquire this X-ray vision into your code to give you those specific targets.
And the secret sauce behind this is called instrumentation. Think of instrumentation like a medical X-ray for your smart contracts. When you run a coverage tool, it actually compiles your tests by inserting intermediate representation hooks, which are basically just tiny little counters right into your code paths. So during execution, every single time a line or a branch is hit, that counter increments.
Then, the tool takes all that raw data and maps it straight back to your source code. It creates this direct relationship. A specific source file and line range equals a specific hit count. Now, a quick heads up here, if you see a hit count of 0, it doesn't mean your bytecode just magically vanished from the compiled contract. It simply means that during your test runs, absolutely no traffic traveled down that specific instrumented path.
Which brings us to Section 3, Triaging Uncovered Code. The crucial takeaway here is that once we find those zero-hit paths, we need a solid triage system. Because, let's face it, not all uncovered code is created equal. If we map this triage system out, you can see exactly how we rank severity. Uncovered public entry points? Those are incredibly high risk since they are directly exposed to users and funds, so you've got to write tests for valid, invalid, and access control checks immediately. Complex conditionals? They'd love to hide nasty combinatorial gaps, and error handling paths are absolutely critical for safety. They require intentional revert tests. Meanwhile, your internal helpers that aren't exposed, they carry a much lower risk, and honestly, you can usually defer testing them unless they're being heavily reused.
In fact, across our advanced learning programs here at Forge College, we always emphasize scoring these uncovered gaps based on 3 main axes: exposure, complexity, and impact. So, is it public? Does it have a high cyclomatic complexity with a ton of branching? Does it move funds or alter state? If the answer is yes to any of those, it shoots straight to the very top of your priority list.
All right, Section 4, the coverage workflow. Let's take a look at how this builds into an actual functional workflow schematic for your continuous integration pipeline. So here is your procedural engineering diagram for coverage. Step 1, generate a baseline report from your default branch. This is super important because it anchors your coverage drift detection. You literally need to know if your new code accidentally lowered your coverage. Step 2, run the instrumented coverage locally or in CI using the forge coverage command. Step 3, parse all that verbose data and rank the uncovered locations using those exact triage rules we just went over. And Step 4, create a prioritized artifact for your team to actually review.
Next up, Section 5, Automating with Scripts. Because doing all of this manually every single time is exhausting. Let's pull out our tool belt so you aren't stuck digging through raw alcove files by hand.
By using standard portable shell utilities, you can actually build a really powerful reproducible bash script. We run forge coverage and pipe it with T to capture the output. Then we use grep to hunt down lines explicitly showing 0 hits. After that, we just use awk and sed to format the text neatly and finish it off with sort and head to generate a clean top 10 list of our most severe blind spots. Pretty neat, right?
Now, the ultimate output of this automation machine isn't just a massive, unreadable data dump. No, it's a short, highly focused, PR-ready artifact. It highlights the top 3 critical gaps in your code, explicitly stating what function is exposed, exactly why it's a risk, and precisely what test your engineers need to write to secure it.
And finally, Section 6, the iterative feedback loop. We've reached the last stage of our blueprint, which is all about actually closing those gaps.
This right here is where the magic happens. You take your top 3 list, you add a highly scoped, focused unit test. Then you immediately rerun forge coverage locally. And finally, you confirm that your hit count has registered and the gap is officially closed. By making these fast, small iterations, you completely transform coverage analysis from this, boring reporting chore into a really active empirical history of quality improvement.
Look, if you take away anything from this explainer, let it be this right here. A coverage percentage is a diagnostic starting point. It is not an answer. That overall metric, it's just the beginning of the hunt. It tells you there's a problem, for sure, but you've got to dig into the actual lines and branches to fix it.
And honestly, that leads us perfectly into our next subject, debugging tests. That's where we'll take the prioritized list we just built and learn the techniques to close those gaps efficiently. I highly encourage you to visit forge.college to dive deeper into this explainer's topic, explore our other Web3 learning resources, and truly master your craft. So I'm going to leave you with this. Are you actively hunting bugs in your smart contracts, or are you just blindly chasing a percentage? See you in the next one.